Hey guys, today we're going to take a look at summarizing all of the factoring techniques we've learned so far in this chapter. So when it comes to factoring polynomials, we want to first of all take a look at the number of terms in the polynomial. If there are two terms, in other words the binomial, then we want to look to see if we can factor out a greatest common factor. And if not, then we want to look to see if it fits into our pattern of the difference of two perfect squares. All right, so that's when we're looking at factoring a binomial. Next up, in the most common case that we looked at in this chapter, was factoring a trinomial. Again, we want to start off by looking to factor out any greatest common factor first. Then we're going to check to see if that trinomial fits into one of our two patterns that we learned. Either the sum of those two perfect squares or the difference of those two perfect squares. If it doesn't fit into either one of those two patterns, the next thing we want to check to see is if our trinomial has a leading coefficient equal to 1. Then we're going to find the factors of C that combine to be B. Finally, we're going to look to see if our leading coefficient is not equal to 1. We're either going to use the technique of Kung Fu or split the middle. Lastly, we had a polynomial with 4 terms. If it had 4 terms in it, our first technique was to, or our first strategy was to look to see if we can factor out a greatest common factor from all the terms. And secondly, we were going to factor by grouping. So let's take a look at an example of each one of these factoring techniques. All right, for number one, we're going to take a look and we're going to see that there's 2 terms in this polynomial. So it's going to either factor out a greatest common factor or it's going to fit into our pattern of the difference of 2 squares. Well, I can see that there's a sum between these 2 terms, so it's not going to fit our pattern. Let's see if we can factor out a greatest common factor. 6 divides into 12 and 18, so I know I can factor out a 6. I've got a to the 5th, b to the 4th, and then a squared b. So I am going to take the highest degree that's in both of those, so that would be a squared and b to the 1st. Now my remaining factors then would be 2a cubed, b squared, b to the 3rd, plus 3, and then there's no a squared, and there's no b. So here is my factored completely and down into these 2 factors, 6a squared b times 2a cubed b cubed plus 3. All right, next up, let's take a look at problem number 3 here. When we factor this one completely, again, we're going to start by checking out the number of terms. There's 2 terms here, and now there is a minus sign. So I can tell that there's no greatest common factor. So let's see if it fits our pattern. Are both of these 2 terms perfect squares? And it is true. They are both perfect squares. So we want to make sure that we factor this down into the difference of those squares. So the square root of x to the 4th is x squared minus the square root of 16, which is 4. Now the other one breaks down into x squared plus 4. Remember, these factor down into those conjugates. All right, the instructions say to factor completely. So again, we want to take a look at these 2 factors that we just broke our starting polynomial down into and ask ourselves, can we factor them even further? And you'll see that this is also that same pattern. It's 2-term binomial with a minus sign between 2 perfect squares. So we actually can factor this even further. And this is going to factor down into x minus 2 times x plus 2. And then we're going to carry down our remaining factor here of x squared plus 4. Notice that x squared plus 4 cannot be factored any further. It doesn't fit this a squared minus b squared. Even though x squared and 4 are both perfect squares, there is a plus sign between those 2 terms rather than a minus sign. So our final factored form, as completely factored, are these 3 factors, x minus 2 times x plus 2 times x squared plus 4. All right, let's move on to a trinomial. Here's a trinomial that has no greatest common factor. It doesn't fit into any of our patterns, and I'm just going to factor it with my leading coefficient that has equal to 1. So I'm looking for factors of 12 that combine to be positive 8. So that's 1 and 12, 2 and 6, 3 and 4. The ones that combine to be 8 are 2 and 6, and they both have to be positive. So my two factors are positive 2, y plus 2, and positive 6, so y plus 6. All right, let's look down here at example 7. Again, we have 3 terms. It's a trinomial, and I notice that my first term is a perfect square, and so is my last term. And there's a minus sign in that middle term. So if I go back up here, I'm going to look at my trinomial, and this is actually going to fit into my pattern of first term perfect square, last term perfect square, with a minus sign in the middle there, and it's 2 times a times b. So what are a and b? In order to find out what a and b are, remember you got to take the square root of both of those. So the square root of 25x squared is 5x. The square root of 9y squared is 3y. Now if I if I take 5x and 3y, multiply them, that's 15xy, and I double it, that's what's going to give me this negative 30xy. So this fits into that pattern, and that pattern says that we are going to take this trinomial, this perfect square trinomial, and it breaks down into 5x minus 3y times 5x minus 3y. All right, or another way of saying that is 5x minus 3y squared. All right, so there's a trinomial that fits our pattern. Let's take a look at a 4 term. So 4 terms here. And here's 4 terms, number 10. And so 4 terms, I'm going to look to see if I can factor out a greatest common factor. There are no greatest common factors here. So I'm going to factor this one by grouping. If you remember, grouping says you're going to take those first 2 terms and group them together, and you're going to take the second 2 terms and group them together, and then factor out the greatest common factor. So focusing on these first 2 terms here, there is an x squared that I can divide out of those first 2 terms. And that leaves me with x squared times 3x minus 5. Next up, I'm going to take a look at the second 2 terms, and I can see that I can factor out a 5 from these 2 terms. So when I factor out a positive 5, I'm going to put that out in front here, and then in parentheses, I'll be left with 3x minus 5 again. All right, now when it comes to simplifying these factors here, I can see that I have a common factor in these 2 terms, and that common factor is 3x minus 5. My other factor is what I'm left over with, and that's the x squared plus 5. So this fully factors down to x squared plus 5 times 3x minus 5. All right, my mother keeps texting me, so I must be in trouble. All right, guys, there you go. There's a little bit of a summary and a review of the 4 techniques, or actually more than 4 techniques, that we've learned when it comes to factoring polynomials. Always start with the number of terms that you have, and then work through the list. Factor out a greatest common factor first, if you can, and then look to these other techniques to fully factor that polynomial.